Making a video. Yeah, another draft science video. Christmas, officially. Yeah. Anyway, once it gets on my mind, I keep thinking it. So, I thought I would do a what if video. So I'll just title it What If, and just talk through an idea about what if this is how reality worked. And I haven't really thought it all the way through, so I thought I would make the video as I'm thinking it through. So, if you've followed along as a story so far, I'm basically arguing that the matter in the universe is really can be analogized to a school of fish, and it's just made of fish that can only move only one speed, but they can move in any direction, and it's only when they're moving in some kind of pattern, that their energy is confined. And if they all move in one direction, then their energy is released in that direction. So it's not that their energy didn't exist before, but their energy existed as motion in all directions. And now their energy exists in one direction, then it's focused and more realizable, more visible. But that the energy isn't something that is consumed. It is only converted. You can only take something that's moving straight and you can make it move some other way, and then you can change its direction. But it's always moving a space at a time. It's always moving a Planck constant, let's call it, somewhere, always. And that's the foundation of the universe. So I would say that atoms are held together by something. I was thinking that maybe they're held together by elements that force them, that hook them together, tie them together. But then I was thinking, what if, like gravity, as I think gravity is, and magnetism, it's an external pressure that holds the atom together. So that atoms aren't held together by some kind of internal force, some internal hook, but that it's really just the pressure from the outside that keeps pushing them together, just like gravity. So anyway, what the consequences of that would be? Because it gets kind of interesting when you think of something in an even pressure. If there's pressure evenly around something, it doesn't matter where it's moving or how it's moving, if the pressure is made of the same substance that the thing that's moving through it is moving through it. So there's no resistance created. That the pressure is, that movement is invisible to the pressure. The pressure really only has to do with position or direction. It doesn't have anything to do really with movement. Yeah, well, see, that sort of just doesn't sound right? So I have to make it sound right, or seem right. Alright, so we'll try drawing a little, and then I'll try thinking a little. So anyway, you have the atom. So let's say you have something in the middle, and then something on the outside. So let's say, what if the pressure that holds the electron, that obliges it, is created by an even pressure, distributed pressure all around it. So three-dimensionally, from all sides the pressure is always exerted. And that when, say, another atom comes in close contact, it does the same thing that gravity would do, which is it blocks some pressure. Some of this pressure is reduced. Let's just say it reduces pressure at one end and can create what might be indicated as being more pressure on this side and a minus pressure on this side, and causing things to collide with each other. Alright, so then we can say that this pressure, somehow does exert a real force on these photons, but that it only exerts it when the photons are in electrons. So let's say this is one of the rules of how the game's played. So if two photons come at each other, there's nothing that can happen. The end result is going to be exactly the result that the effective difference will be no difference. So whether you think of it, like I've said this before, but if you think of it as being a kinetic exchange where this bounces off of that and now goes in this direction, and this bounces off that and goes in this direction, it doesn't really matter. The end result is something's going to go off in this direction and something's going to go off in this direction. So whether they go right through each other or whether you think about them bouncing off of each other and reversing, it doesn't really matter. It's going to be exactly the same effect. So the only way you can have effect is to have something other than a direct impact. And then even with an indirect impact, with objects that have, let's say, no ability to change their speed and no ability to change their mass, so they can't change anything about themselves, that this interaction would also be perhaps futile. I have to think about that. I mean, one would think that this interaction will create this would have to be deflected this way, and this would have to be deflected that way, so that the end result is a change in direction, but nothing else changes. But the direction is essentially inverted both ways, horizontally and vertically. So it's a change in direction in two directions, right? It's a rotation 90 degrees in the opposite direction. Okay, so the vectors it's rotated 90 degrees in the opposite direction, which is the same as a horizontal and a vertical flip. Well, anyway, all right, don't want to get into that. All right, so we'll just say I didn't want to make rules, because I just wanted to start over. But I guess the first rule, we have to come up with some reason why this pressure affects things. Well, let's just explain why this pressure can't have an influence in the real world. So let's just say this thing is moving. Well, see, its movement would have to be explained if it's made out of, let's say, moving parts, as I'm theorizing. But let's not do that for this. Well, see, there's no real way to do it without always going back to the school of fish, without always going back to the smallest bits, and recognizing that when you see a school of fish, it's not a school of fish. It's just individual fish. You can't interact with it as a school, and in a sense, you don't interact with atoms or electrons as atoms or electrons. You're only interacting with the tiny portion of them your fish interacts with, or the fish on the periphery of your school. So if your school collides with another school, there's only individual fish that are interacting. There's no school that's interacting. Maybe that's a good way to put it. So you have to think of this pressure as these things being made of these discrete bits. And it's the same kind of discrete little bits that are creating the pressure. So the question is, when they're creating this let's say I accelerate something through the space of pressure. So I give something momentum, and it's moving through this constant pressure field. So there's a thing, and it's moving in that direction. And there's still a constant pressure all around it. So the pressure is not adding to its acceleration. But you would clearly say, well, its movement is going to create more force, right, against the pressure in this direction. But that's where the trick is. That's where the catch is. The fish can only move one speed. So the fish in this school, the only reason why this school is moving is because the fish aren't doing this anymore. They're doing some other shape. So instead of doing some shape that keeps them in one place, they're doing a shape that is eating space in this direction. So they have to be swimming in some kind of pattern like this. Some kind of pattern that instead of being a circle, instead of doing this, they're doing this. So instead of being a coiled spring, they're doing an uncoiled spring. And that's the only way they can be moving, is that more of them have to be doing this than are doing this. And then when you understand it that way, you understand that it's only fish interacting with that force, and therefore there's no pressure from the force. Right. Yeah, it's correct, but it still doesn't. So, I mean, it explains why it's invisible to this force now, because we can understand that from its perspective on the checkerboard, right? If you reduce it to a checkerboard, its pieces are only moving 1x at a time. The force is only applying a force 1x at a time. Everything's moving the speed of light. So everything has there's no change in force. There can only be change in direction. Okay. There's no extra change in direction because the increase in speed doesn't change the nature of impacts, but you could argue what is changed is the frequency of impacts. So we could argue that if the force in this direction is represented by 5 pressure, well 3, I'll just make it easier, and there's 3 pressure lines moving in this direction. And again, the thing is moving in this direction. So you have equal force behind and equal force coming at it. Why is it still neutral? Why does it just keep going? Like if something's accelerated in space, it just keeps going. Its direction isn't changed, even though it's moving through a pressure gradient. So it's a gradient capable of creating gravity, which means it can, at any moment it's shielded from pressure, it will be forced to move towards something. And yet, it moves through the even pressure as if the pressure doesn't exist. Right. So, so as long as this pressure is even, how is it affecting something that's moving by not changing the nature of its movement? We would expect that if it's moving, that it's getting less of this, it's feeling less of this because it's always ahead of it. Like no matter how fast if this is going the speed of light, and this is going the speed of light, this force could never catch up to this, you know. But it isn't this that's moving the speed of light, it's the pieces inside of it that are moving the speed of light. So yes, this velocity always has to be less than the speed of light. So there's still some element of this force that is affecting it, but depending on how fast this thing is going, if it's going in, well, that's the trick, is the speed of light is so much faster than anything material can move. Matter can't move anywhere near the speed of light. So this is never really tested because it's so much slower than the speed of light that from the thing's perspective the pressure is equal. But you'd have to say it's still enough of a difference. You know, if it's going 50 miles an hour this way, it's still 50 miles an hour off of this pressure. Correct? Correct. But the catch, again, we'll go back to the catch. The catch is, it's not 50 miles an hour for all the pieces. All the pieces of this matter, some of the pieces are moving the speed of light in this direction, some of the pieces are moving the speed of light in this direction, and it's only that there's a slightly more of them are moving the speed of light in this direction than are moving the speed of light in this direction. And it's only a slight amount. So if you think about 50 miles an hour in the context of the speed of light, you would realize that it's only a tiny percentage of the fish in the school that have to be going this way more. So if only 1% more fish are going this way, this direction, than are going that direction, that would equal 1% of the speed of light in terms of acceleration. And 1% of the speed of light is still 18,000 miles a second. And we don't know any matter that can go that fast. So we're talking about something, we're not talking about just 1 in 10. We're talking about 1 in 100 or 1 in 1,000 or 1 in 10,000. So it's only 1 in 10,000 more. So 999,000 go this way and 10,000 go that way. It's only one tiny 1 in 10,000th difference in the pressure of the internal movement of the matter that would create something like 50 miles an hour. It might be 1/100,000th. So it's only a tiny differential. Yeah, so that's important. But it's still a difference. And as far as we know, there's even that kind of difference would create some sort of drag. There'd be some kind of, your velocity would slow down as you move through this force. But the catch is, back to this argument, anything doing this straight on thing has no effect. There's no change in the disposition of energy. So again, that 10,000th is not going to matter because the kinetic effect is completely made zero. So in the direction that something's moving, the very reason it's moving in that direction is because the fish are moving in that direction, and two fish that swim into each other have no it's a zero event. Two fish that swim right into each other, it's a zero event. No energy loss, no change in direction. So this is zeroed as a lagging force because its interaction is with that one extra fish that's going head first into it. That would explain it. Yeah, quite well. So anyway, okay, so that's why there's no drag as something accelerates through the pressure gradient, is that any pressure in the direction of a gradient, in the direction it's coming from, any direct force is kinetically zero. It's indistinguishable from no contact. The same exact effect. So again, I'm back to this argument, but you can sort of understand it. If you can't change, if the only thing you would change is direction, if you can't change speed and you can't change mass, there's no other thing that can be changed through a direct hit of the opposites. It's a non-event. It's as if the two things didn't hit each other. Okay. Yeah, I've said that enough ways. It's a curious fact, if you think about it, that even in real pool ball physics, it's sort of a reality. That if you have two things moving exactly the same speed and they collide directly into each other, it's a non-event. One thing leaves the same speed as the other thing. You know what I'm saying? It's like they either go through each other or they bounce directly off of each other, however you interpret it. But it doesn't matter. Kinetically, it's a non-event. Okay. That is if they can't be chipped or heat up or do any of this other stuff. There's no other way to transfer energy except in changing direction. Even though that's not really a transfer of energy. Alright, so anyway, so back to this idea of the pressure being the pressure that's holding the universe together, even atoms, being this photonic pressure. So now we have these photons that exist but can only be detected because they create acceleration in matter. So that's sort of what gravity does. Gravity is detected because it will accelerate matter. So you put matter in gravity and it starts to accelerate. Right? Follow me? Yeah. So it's and why it's accelerating, one could argue, if we're going to do this thing, is because of this shadowing effect. So it's the excess pressure, it's the reduced pressure from the shadow. So the gravity is, so when these two things are next to each other, this force here is to some extent reduced in its impact on this surface, and this force going this way is reduced on this thing's surface, which compels them both to accelerate, and they just happen to be accelerating towards each other. But the acceleration is inside of them. So again, the acceleration is a manifestation of the change in direction of the fish that they're made of. So the bits that they're made of are now arranged in the direction of the pressure. So as the pressure comes through, it changes the directionality, the overall direction of things. So if it's in even pressure, if a thing is under even pressure, there's nothing accelerating it. It means the thing goes through and comes out the other side. This also goes through and comes out this side. This goes through and comes out this side. This goes through and comes out that side. So there's always an equal influence on this thing. So if you said that this pushes a little as it goes through it, it nudges it a little in this direction. And then you could say that this one nudges it back in that direction. And that this force nudges it a little in that direction, but then this force nudges it back in this direction. So the pressure is even, so it's nudged, it's vibrated, it's moving, it's being jiggled, but it doesn't go anywhere because the pressure is even on all sides. So the pressure is exerting, is transferring energy in the sense of, as it goes through, it's creating a it's creating a change in, say if it was a circle. All right, and if you hit the circle, what you did was basically pop the circle open, and now the circle circled in this new circle. So when you hit it, you create a mouth, let's say, in a sense. So if the circle's going, if the circle's going this way, and let's see if an arrow helps at all. So it's spinning this way. If I hit it here, what happens is that now the circle is changed, because now the opening is here, and now the rest of the circle follows that shape. Or I could also argue that it goes through and hits the back side and does the same thing. Or I could say it goes through and it opens the gap here, which is more visible. I mean, you could argue that if it hits the back end of the circle, you could see the gap opening more easily. You could get the idea of the overlap. So if the idea of thinking of the energy coming in this way and then popping this open, you could get the idea more easily that now it's been shifted one Planck constant of distance in this direction, and that it will follow up with that new position. It'll stay in that position unless something affects it to change that new orientation, or maybe that yeah, so it's neutral to the pressure. Now, again, the acceleration is creating a semi-permanent condition. But gravity isn't permanent, right? If I create acceleration in something and I turn gravity off, it'll no longer accelerate. It'll still maintain the speed it has, but it won't gain any more speed. Let's see, if I push something in space, it's not accelerating, it just has momentum. So there's no 16 feet a second per second thing. It's not gaining speed, it's just maintaining speed. You still have to explain what shape dynamic is creating that. So one could argue that the whatever changes are made, the fact is once this thing is opened, it would stay open. I guess that's the argument to make. It would just keep eating space in this direction. It would just keep doing this if it wasn't for the fact that this equalizing pressure will close that gap. So that's the key here, is that one piece of pressure starts to unwind the spring, and then the reverse pressure closes the spring down again. So you could say that the native state is a spring wanting to be opened, but that the pressure just keeps closing the spring, and it keeps opening and keeps closing and keeps opening. It keeps so that's why this uneven pressure keeps opening more springs in one direction than it's closing in the opposite direction. So as these things unwind, there's more pressure causing unwinding in this direction than there is pressure closing those same openings. Okay, I think that's, you either followed that or you didn't. Yeah. So where do I want to take that from? Yeah, I still want to get back to atoms and their movement. And even the electrons moving, because electrons are very curious. But that's, you get into this. Electrons are what's doing this opening thing, obviously, and electrons are doing the thing that's probably dragging everything in one direction or another direction, because they're getting impacted more than anything else is. Alright, but I still want to get to this idea of this force. So it's a pressure that's constantly applied. If you're moving in the direction of the force, it's zeroed through this circumstance. So there's no lag, there's no friction as you move in the direction against the force. So you can't, so there's no drag. So if you have a movement already, if you already have a certain number of springs already unwound, okay, so I put you in the position of accelerating, which means a certain percentage of your springs, a very small number, are now unwinding. And most of your springs are still going in a circle, most of them are still tied up, but a certain percentage more are unwinding in this direction than in this direction. And with that tiny difference in percentages will create very high speeds. So you could be going 100,000 miles an hour. It's very fast, 100,000 miles an hour. Light's going 180,000 miles a second. Right, so 1 second to an hour plus 100,000 is only 60% of 180,000. So you're still way not even close to the speed of light. 1 second to an hour at 100,000 miles, 180,000 miles an hour, right? Which is really 180,000 miles an hour, really fast. And yet, the difference between it and the speed of light is the difference between 1 second and 1 hour. So when you think about these speed differences, this is what makes some of this physics incoherent. Is that I can say 100,000 miles an hour, I can say 180,000 miles an hour, I can say at 180,000 miles a second, I can say it, but you can't cognize it, and you can't appreciate that that's the world these fish are living in. That's the school of fish. That's their frame rate. Their frame rate is so much faster than our frame rate. Our frame rate is, you know, one second to us is 10,000 years to them. There's that kind of difference in the time scale, in our perceivability of how much stuff is happening. It's 10,000 years of stuff happening to them in 1 second of our perception. There's 10,000 interactions, 10,000 years of interactions in our 1 second. Power just blipped. I could hear it at the road. You see, when the tree branches hit the high voltage lines, you know, it shorts them and they go zzz, and they start to fry, and the lights dim a little. You get a little blip, and you get a little sound. Zzz. You can hear it in the wires. There's a frequency that the branch is bouncing on the voltage. So you get the frequency that the branch is bouncing, and you can hear it in the electricity in the house. It's kind of neat. Anyway, but just the photons, just the number of photons shooting through these wires. I think it is photons, not electrons. But anyway, that's a whole nother story. Okay, so anyway, so we have this simple rule that if you're moving in the direction of a force, there's zero drag, zero kinetic activity. It's a non-event. So there's no friction from anything in your way. So there's no glue to the pressure. It's invisible to your force as long as it's in the direction of your force. So if all the fish are moving in one direction, they can't be impacted by something moving in the direction of their force. It has zero effect. They just go right through it. Forces from other sides can affect them, but nothing can affect them in that direction. So this would probably be a good place to argue that gravity has no effect if you're moving in the direction of the gravity. So if an object is moving in the direction of gravity, there would be no, well, there's no point in me getting through this, right? I'm just wondering whether there's an increase in acceleration consistent with gravity if the velocity is in excess of gravity already. Sort of an interesting question. Because the force is actually being applied in the opposite direction, well, again, see, anything going with it is also going to be irrelevant. As we're saying, these pieces are moving the speed of light. So if you're going in this direction, because some proportion of you is moving in that direction, but the point is the pieces already moving in this direction aren't the pieces that are getting changed by gravity. So the point is that the force is only going to be affecting things that aren't already going in the direction of the force. So again, if you're moving in the direction of the force is irrelevant, and because this is moving the speed of light and the force is moving the speed of light, so there's absolutely no way for this force to affect something already moving in the same direction it's moving in. And likewise, the inverse is this kinetic argument that the force is moving exactly with you, against you, it also is zero. So it's zero with you or zero against you, but all the other things still moving in some other direction, some other piece of you that's still doing the circle thing, not the spring thing, those things can still be affected. So a higher percentage of your mass will be pointed in the direction of the gravity. So you will be accelerated because more of your mass will be converted into moving in the direction of your acceleration. problem didn't need to get into. So yes, you will gain acceleration even if you're moving faster than even if you're accelerating faster than the acceleration of gravity. So even if you have a rocket pushing you towards the Earth, the gravity is still going to add to your velocity. Yeah. All right. So what else do I have to add here? What do I want to get to? Well, I think this got to something. Then I mean, we can understand why there's no drag from this pressure that is so momentous. There's this huge pressure all around us right now. Tons. It's so dense and so thick it can move planets. There's so many of these photons. And so again, I guess I think to explain is what I think these photons, what shape they're in. So my argument would be that the photons we recognize are recognized because they possess a frequency. So that is, there's a distance between them. So that we could say that this is 3 miles. We could say that that's a radio wave, of 3 miles, and that the smallest one would be some sort of gamma ray or whatever the hell, cosmic ray, whatever the smallest one is, somewhere after an X-ray, and that it has the smallest period, the shortest period. So it's really not about the photons. The photons are all the same. It's about the distance between them, so the period of them. So obviously in a given moment of time, you might only get a piece of a radio wave, and you might only get 2 photons of infrared light, and you'd get 4 photons of ultraviolet light. Say ultraviolet's twice as dense in terms of the wavelength is half the distance of, say, infrared. It's a generalization, but it's pretty close. So what makes ultraviolet light more intense is the fact that there's more photons in the same period. So the same period of time, I shouldn't say same period because the period is smaller. The period is described as the distance between occurrences. And so I would argue that what these gravitons are, and these magnetons, so let's just call them gravitons and magnetons, the things that are creating the force of gravity and magnetism, they're photons, okay, that don't have a frequency. So they don't have any, there's nothing they're not in any pair configuration. So what I would argue is that electrons and atoms can't convert a graviton into something, and they can convert, say the dumbbell idea, the idea of 2 photons of infrared. So infrared light is always at least 2 photons. So when we say a photon of infrared light, we're really just saying 2 photons, because what identifies the character of the thing we're calling it, it can't be infrared if it doesn't have that period, if it doesn't have that frequency, and that frequency is created by the frequency of the photons, the arrival of them. So the graviton has this disadvantage. So infrared light comes in, and so I'm sort of going to be making this tipping argument. So you have a pedestal. If I hit it with 1 photon, okay, I might move it a little bit, but it'll rock back. So I'll create a little motion in this direction, but the equal and opposite reaction will take it back to its center, and it'll re-find its center, because it has time. But if I hit it with 2 in succession quickly enough, then it will be moved by the first one, maybe come back a little, but not enough, and the second one hits it and knocks it past its tipping point, and it'll fall all the way down. So I'm saying there's a similar mechanism in this thing called an electron circling an atom, where if a graviton hits it, it can bulge it, it can push, an opening, a change in the direction of a photon, So it'll move one photon, one Planck constant, but it also leaves. So it might have a change in direction and through that influence. So it might go in this way and come out that way, meaning that now it's lost its directionality, and so now there's less. This pressure that came in here, it came in here as pressure. It hit an electron, changed its direction, so now there's more pressure going this way, and now there's less pressure going this way, and so that would be the shadowing effect. But it's not lost in that it's still an active photon, and it will create pressure on some other thing. So it just adds to the pressure density of the environment. It's still in the environment, it's still loose, and all it's done is change the momentum, the direction of this one atom, by moving it one space in that direction. So it's dragged this one photon, one Planck constant, it's moved this electron one Planck constant in this direction, in the direction of its momentum, and for that exchange has changed its direction. And but when something with a frequency comes in, the first photon probably does this bending, this opening, this pushing, and then because the second one comes within a sufficient time, so this time interval means that this gap is here now, this bulge from the first one, and then the second impact takes place, and maybe that has something to do with breaking or dislodging some portion of this electron, and it releases something, 2 photons or some, it will end up doing something mechanically representative of what just happened. It might even just be that this first one goes through and hits, and then it hits the back end or something. Or who knows what's going on in the center. See, the center is going to be affected by this too. It's being pushed by this pressure also, so I'd have to explain what's going on in the nucleus of the atom also. But I mean, it might get too complicated. I guess what I'm saying is I don't have the detailed map of why some, like orbits, the orbits of an atom, clearly what seems to be happening is that some orbits of the atom are vulnerable to the impacts of infrared, and then some are vulnerable to the impacts of ultraviolet. So this short period versus this long period makes a difference in terms of what this electron does, or this electron, in terms of whether this one might jump to a different energy level because of this impact, because it might be fully absorbed. As I said, the first one goes in, and and then the second one goes in, or one goes in, gets pushed this way, and the second one fills in that gap. I don't know. I mean, I don't know. I have to really, that's another what if thing, where I could just go microscopically into that one element of trying to figure out exactly how these different photons have different effect, and that these things called gravitons have so little effect, and that there's absolutely no. See, we know what happened. We know what heat is created by. We know that heat's created because you send in 4 of these ultraviolet light things in a time interval, and you release, through some process, you absorb, say, 2 of them, and then you release 2 of them as infrared radiation. So you release 2 as another set of photons that will cause more activity in the structure, the environment. Where the graviton was exactly the same going in as what out. There's no extra heat being created. It's not forcing the atoms to release any extra electrons. Where extra photons can be produced from electrons through interactions with visible kinds of light, or invisible ultraviolet light, or invisible infrared light. Okay. They're obviously they're causing electrons to lose energy, which creates more energy in the environment, okay, which is the heat. So the reason why gravity doesn't create heat is because there's no release of any other photons in the process of creating this slight impetus in a direction. Okay. I think I still to be clear, it's not an impetus in a direction, it's a tendency to move in a direction. Again, we're going to argue that what happens to this electron when it's impacted by a graviton is that it gains acceleration, which means that it now has this coiled spring is now allowed to move in this kind of manner. It's more tighter than that, but it's now going to eat space in a direction. It's now opened at one end. So one end of the electron is opened, and now it eats space in the direction of that opening, which can't really happen. If this was a perfect circle, then it would be eating space in all directions. So it has to be an ellipse. It has to be in a configuration where it's eating space in one direction. So you have to describe that as having a shape where it's oblong. These two sides would be neutral, and this side would eat more space than this side. So it goes, it's sort of like a paramecium. Parameciums are deceptive. Yeah, back to parameciums. That's kind of funny. Alright, so yeah, so what happens is it changes the shape of the orbit slightly. Okay, this is probably a huge exaggeration, but I'm just doing it for the sake of the argument to point out that if this is a constant speed, so it's always moving at the same speed, it's cycling, so it's moving around and around and around, and there's one little flare, one little opening. So now what happens is we can see that these two sides are equal. So there's an equal amount of opening happening on both ways, both sides here. So directionally it eats as much space in this direction as it eats in this direction. So those two are nullified. And the difference is that it's going to spend less time in this direction than it will spend in this direction. Well, I did that backwards. But you can see that, so going this way will be a bigger arrow than the this way direction. So now the bigger arrow is in this direction than in this direction in time, and being that this thing always moves the same speed, unlike like when a planet is in an ellipse, it moves faster when it's at the smaller part of the ellipse, and it moves slower in the wider part to make the overall circle even, in a sense, in terms of time. But you can't make it even because these are photons moving the speed of light. So they're always moving the same speed. So they'll spend less time, so the opening will spend less time eating space in this direction and more time eating space in this direction. So it's the change in the shape of the orbit that'll decide the direction that the atom is dragged in by the electron. Yeah, okay, I like that. So I have to remember that. Alright, so I guess the other thing I want to point out is part of this explanation would have to explain what this electron is, and I'm saying the electron is basically photons of no wavelength. So the electron is basically just a string of photons with no wavelength. They're just stuck to each other. So they could just be S hooks, and they're just S hooked into each other like that. So the hooks just hook, and that's a photon. That's a photon. That's a photon. And it's when they're released, and then released with a specific frequency, that they become photons that we recognize. But they're invisible unless they're at specific frequencies. We only see visible light. We only see. We only feel certain kinds of photons. We don't feel radio waves. We don't feel microwaves. We kind of feel gravity, but I guess we don't sense it directly. We sense it indirectly in the sense that we feel the pressure of the atmosphere. We feel the pressure of everything else that's being pushed, that's accelerating with us. So the stuff that's accelerating with us is moving past us as it's accelerating with us. This air here is, I guess it isn't really stable. I mean, it's also blocked by pressure, so I guess that's part of it too. The molecules in this air right here, like the pen will fall because there's no pen below it to hold it up. But the atmosphere has atmosphere below it that's already under pressure. So the atmosphere doesn't need to move, but this pen does, because there's nothing equally dense below it to stop it from moving. But we're being accelerated right now. Right now I'm technically moving. I'm just keep getting pushed back up again. So I'm accelerating, and then there's an equal and opposite reaction from the pressure below to push me back up again. I don't feel that, but it's happening. Because I am in a state of acceleration. I'm being moved, 16, is it 6, I always forget, 16 feet per second. So every second I'm moving, my molecules are being moved 16 feet. And from their perspective, pieces of me are going, and the net balance is nothing, because the force of the not compliant below me is forcing me back up, but it's also being heated. It's also being pressurized by my pressure of my acceleration. So my acceleration is essentially pushing other stuff up, in a way. But it's all happening with the little tiny fish, and we can't see the little fish. But if you could see the little fish are really they're really active. Gravity is causing the little fish a lot of tension, a lot of movement, a lot of energy, a lot of directional changes. We just can't see it. It's a really little fish. Alright, I think I did what I needed to do here. So I think it is theoretically possible, anyways. What I wanted to get to is the bottom line point. That what's holding atoms together is actually the same pressure, the same gravitons and magnetons that are moving us. That it is all just photons, and it are photons that are keeping this orbit. They're forcing this orbit. They're forcing electrons into the shape they have, because as they move, they keep getting pushed by a graviton. Yeah. And the nucleus is shielding them from the ones coming from this direction. So that was the part I left out. So it's the same force as gravity, in the sense that the nucleus creates the shadow that keeps forcing the acceleration towards the center. Get it? Yeah, I get it. Yeah. So, yeah, it does make sense to me. But anyway, so more to go. And so I'll try this again maybe. But anyway, I needed to think through this, and this was not a bad thinking through. I mean, this did not work. This almost does work. So I like it. I like it especially because, you know, my old model, I had to figure out that there was some sort of string, you know, from the nucleus to the electron, you know, a string of photons or something that was forcing the orbit. And that was getting a little complicated. Still might be there. But gravity makes a more sensible explanation for how things get migrated. You could almost argue that if we moved all the planets over, you know, a few thousand miles or something, moved them all in one direction, a few thousand miles at once, that the sun would have to follow along. That the opposite gravitational forces that the planets are imposing on the sun would accelerate the sun in this new direction. Yeah, something like that. Okay, that's enough. I'll be back later. And such. So, happy original lie day. Yeah, the Jesus, religion, God, bullshit. Happy Physics Day. We'll just call it Happy Physics Day. Yeah, that's what we should just change it. Merry Physics Day. Everybody should do physics on Christmas. Yeah, because that's the God. That's our creation. This is our creator. This is the Jeebus. The ultimate Jeebus. This is the model of it. Yeah. Okay, I haven't drawn a really good picture of it yet, but it's still an ugly as when somebody draws the real picture, it's still going to be ugly. It's an ugly truth. We're just eccentric movement in a school of fish. That's what we are. Funky fish.